In this second video on binomial theorem, we will discuss how to find the general term in the binomial expansion, how to find the middle term in the binomial expansion when the number of terms is even or odd, and we will discuss some representative examples based on binomial theorem. Hello friends, you are watching YouTube channel Number Collage. This channel features easy to understand concept videos on mathematics. Effort has been made to explore the mathematical concepts through the basic ideas in mathematics. We will see how to find the general term of the binomial expansion. In the first part of binomial theorem, we have understood how to write the binomial expansion of a plus b raised to n, which is nc0 a raised to n b raised to 0. Here this 0 is r, which is the order of the term, and this is our first term t1, where this 1 is formed by adding 1 to this r, which is 0. The second term is nc1 a raised to n minus 1 into b raised to 1. This is the second term t2, where this 2 is formed by adding 1 to the value of r, which is 1. So 1 plus 1 is 2, plus nc2 a raised to n minus 2 b square, which is the third term t3, where this 3 is 1 more than the value of r, which is 2. 2 plus 1 is 3, plus n c 3 a raised to n minus 3 b cube, which is the fourth term, where this 4 is 1 plus the value of r, which is 3. 3 plus 1 is 4. So we can go like that and conclude that the r plus 1th term, that is t r plus 1, will be n c r a raised to n minus r b raised to r. This r plus 1th term is also called the general term of the binomial expansion a plus b raised to n. Next, we will see how to find the middle term of the binomial expansion. We have already seen in the binomial expansion of a plus b raised to n, there will be n plus 1 terms in the expansion. Now suppose if n is even number, say 4, then there will be n plus 1, that is 4 plus 1, 5 terms in the expansion. Say T1, T2, T3, T4 and T5. Obviously, the middle term will be the T3 term, which is obtained by this n plus 1 upon 2, that is 5 plus 1 upon 2, that is 6 by 2, which is 3. So the third term is the middle term, that is T3. If n is an odd number, say 5, then there will be n plus 1, that is 5 plus 1, or 6 terms in the binomial expansion, say t1, t2, t3, t4, t5 and t6. So there will be two middle terms instead of one, t3 and t4. This t3 will be n plus 1, which is 6 upon 2, that is 3, third term, and this t4 will be n plus 1 by 2 plus 1, that is 3 plus 1, or fourth term t4. So therefore when n is even, there will be one middle term given by n plus 1 plus 1 by 2, and if n is odd number, then there will be two middle terms. The first will be n plus 1 by 2 middle term, and the second will be n plus 1 by 2 plus 1th middle term. So there will be two middle terms like this. In the binomial expansion of x plus 2y raised to 8, there will be 8 plus 1, 9 terms in the expansion. So the middle term of the expansion will be n upon 2 plus 1. Here n equals 8, so it will be 8 upon 2 plus 1, fifth term. So the middle term in this case will be t5, fifth term. In the binomial expansion of 2x minus y raised to 7, there will be 7 plus 1, 8 terms in the expansion, which is an odd number. So therefore, there will be two middle terms in the expansion. The first middle term will be n plus 1 upon 2, which will be this 7, which is n, 7 plus 1 upon 2. That will be fourth term, t4, and the second middle term will be n plus 1 by 2 plus 1, that will be 4 plus 1, that is fifth term, that is t5. So t4 and t5 will be the two middle term when the index is an odd number like 7. Next, we have to study term independent of x, which means term which is free from x or which does not contain x, or in other words, it is a constant term. We can get terms independent of x or constant term in the binomial expansion of the kind x plus 1 upon x raised to 2n. Here, for any positive integer n, 2n will be an even number and the total number of terms will be 2n plus 1, which will be an odd number. And when the number of terms is an odd number, there is a single middle term, which will be this 2n upon 2 plus 1, which will be this 2 gets cancelled, n plus 1th term. We have learned in the binomial expansion of a plus b raised to n, the general term is tr plus 1 given as n c r into a raised to n minus r into b raised to r. Therefore, the single middle term in this case, as we have found out, will be n plus 1th term. So comparing t n plus 1 with this general term, the middle term t n plus 1 will be this n, which in this case is 2n c, then this r, which in this case is n, multiplied by this a raised to n minus r. Here it will be x raised to 2n minus n multiplied by 1 upon x raised to r, which will be n here. So it will be 2n cn x raised to n multiplied by 1 upon x raised to n. X raised to n cancels with this x raised to n, and we are left with the middle term t n plus 1 equals this 2n cn, which is a constant. Hence, for this binomial expansion, the term independent of x will be this tn plus 1, which is 2n cn, and it is going to be a constant term and hence independent of x or free from x. We have to write the general term in the binomial expansion of x square minus y raised to 6. Here this x square is a, minus y is b, and n is 6. The general term in the binomial expansion is given as t r plus 1 is equal to ncr a raised to n minus r into b raised to r. It will be 6cr into x square raised to 6 minus r into minus y raised to r. This will be 6 factorial upon 6 minus r factorial into r factorial multiplied by this will be x raised to 2 times 6 minus r multiplied by minus y raised to r. It will be 6 factorial upon 6 minus r factorial into r factorial multiplied by x raised to 12 into x raised to minus 2r into minus 1 raised to r into y raised to r. So the general term tr plus 1 will be minus 1 raised to r into this will be 6cr into x raised to 12 minus 2r into this y raised to r. So this will be the general term of this binomial expansion. Next, we will see how to find the coefficient of a specific term in the binomial expansion. We will see how to find coefficient of x raised to 5 in the binomial expansion of x plus 3 raised to 8. Here x is a, 3 is b, and 8 is n. The general term in the binomial expansion is tr plus 1 equals ncr into a raised to n minus r into b raised to r. So in the expansion of x plus 3 raised to 8, it will be 8cr into x raised to 8 minus r into 3 raised to r. Here this x raised to 8 minus r equals x raised to 5. Equating the indices 5 and 8 minus r, we write 8 minus r equals 5. That will be r equals 8 minus 5, that is 3. Now we will put r equals 3 in this t r plus 1. So that will be t 3 plus 1 equals 8c3 into x raised to 8 minus 3 into 3 cube. Since here r is 3, we will write the three terms 8 multiplied by 7 multiplied by 6 in 8 factorial divided by 3 factorial, which will be 3 multiplied by 2 into x raised to 5 multiplied by 3 cube, 3 multiplied by 3 multiplied by 3. Now this 3 cancels with this 3, then 2 ones are 2 threes are. So T4 will be 8 sevens are 56 multiplied by 3 threes are 9, 9 threes are 27 into x raised to 5, which will be 1512 x raised to 5. So therefore the coefficient of x raised to 5 will be 1512. In the next problem, we have to find the coefficient of a raised to 5, b raised to 7 in the binomial expansion of a minus 2b raised to 12. Here, this a is a, minus 2b is b, and this 12 is n. The general term of binomial expansion is tr plus 1 equals ncr a raised to n minus r b raised to r. By substituting these values, we write the general term tr plus 1 equals 12 cr into this a raised to 12 minus r into this minus 2b raised to r. This will be 12 cr into a raised to 12 minus r into minus 2 raised to r into b raised to r. Here this b raised to r equals this b raised to 7. Comparing the indices, we get r equals 7, so that the general term become t 7 plus 1 equals 12c 7 into minus 2 raised to 7 into a raised to 12 minus 7 into b raised to 7. So that will be T8 equals, we write this 12C7 as 12C 12 minus 7 multiplied by 2 raised to 7 minus 128 into a raised to 5 into b raised to 7. So that will be, since 12 minus 7 is 5, we will write 5 factors of 12 factorial, that is 12 multiplied by 11 multiplied by 10 multiplied by 9 multiplied by 8 upon 5 factorial, that is 5 multiplied by 4 multiplied by 3 multiplied by minus 128 into a raised to 5 b raised to 7. Now here 5 twos are 10 cancels with this 10, 4 threes are 12 cancels with this 12. That gives us minus 10 13 76 a raised to 5 b raised to 7. So minus 10 13 76 is the coefficient of a raised to 5 b raised to 7, a raised to 5 b raised to 7. Next we will see how we can find the specific term in the binomial expansion. We have to find the fourth term in the expansion of x minus 2y raised to 12. The general term in the binomial expansion is tr plus 1, which equals ncr a raised to n minus r b raised to r. In this binomial, x is a, minus 2y is b, and 12 is n. And since we have to find the fourth term, this r plus 1 will be equal to 4. That will give us r equals this 4 minus 1, that is 3. So our fourth term t4 will be 12 c r, which is 3, into a, which is x, raised to n minus r, that will be 12 minus 3 multiplied by minus 2y raised to cube. Because r is 3, we will write only 3 factors of 12 factorial. 12 multiplied by 11 multiplied by 10 divided by this 3 factorial, which will be 3 multiplied by 2 into x raised to 12 minus 3 is 9 into minus 2 cube into y cube. Now here 3 twos are 6, 6 twos are 12. So T4 will be 11 twos are 22, 22 multiplied by 10, 220 multiplied by minus 2 cube is minus 8 into x raised to 9 y cube. So finally, the fourth term of this binomial expansion will be minus 22 8s are 176 0 x raised to 9 y cube. So this will be the fourth term of this binomial expansion. Next, we will see how we can find the middle term in the binomial expansion. We will find the middle term of the binomial expansion 3 minus x cube upon 6 whole raised to 7. In this binomial, 3 is a, minus x cube upon 6 is b, and 7 is n. Since n is 7, there will be 7 plus 1, 8 terms in the expansion. And since 8 is an even number, there will be two middle terms. The first middle term will be this 8 by 2, that is fourth term t4, and the second middle term will be next to t4, that is t5. The general term tr plus 1 is ncr a raised to n minus r into b raised to r. In the first middle term t4, r will be 4 minus 1, that is 3. So therefore t4 equals ncr, which will be 7c3 multiplied by a raised to n minus r, that is 3 raised to 7 minus 3 multiplied by b raised to r, that will be minus x cube upon 6 raised to r, which is 3. Since r is 3, we will write first 3 factors of 7 factorial, that is 7 multiplied by 6 multiplied by 5 upon 3 factorial, which is 3 multiplied by 2 multiplied by 7 minus 3 is 4, and 3 raised to 4 is 81 multiplied by minus 1 upon 6 cube multiplied by x raised to 3 threes are 9. Now here 3 2s are 6, cancels with this 6, so it will be 7 5s are 35 multiplied by 81 multiplied by minus 1 by 6 cube will be minus 1 upon 216 multiplied by x raised to 9. Now here 9 9s are 81, 9 2s are 18, 9 4s are 36, 3 3s are 9, 3 8s are 24. So T4 will be 35 3s are minus 105 upon 8 into x raised to 9. So we write the first middle term T4 equals minus 105 upon 8 x raised to 9. Next we will find the second middle term, which is T5. For T5 R will be 5 minus 1, that is 4. So we write T5 equals this NCR 7C4 multiplied by a raised to n minus r, that is 3 raised to 7 minus 4 multiplied by b raised to r, that is minus x cube upon 6 raised to 4. Now here r is 4, so therefore we will write 4 factors of 7 factorial. 7 multiplied by 6 multiplied by 5 multiplied by 4 upon 4 factorial, which is 4 multiplied by 3 multiplied by 2 multiplied by 7 minus 4 is 3, and 3 cube is 27 multiplied by minus 1 upon 6 raised to 4 will be 1 upon 216 multiplied by 6 into x cube raised to 4 will be x raised to 12. Now here 3 2s are 6, cancels with this 6, this 4 cancels with this 4, 9 3s are 27, 9 2s are 18, 9 4s are 36, 3 1s are and 3 2s are. So that gives us T5 equals 35 upon 24 2s are 48 x raised to 12. So the second middle term T5 will be 35 upon 48 x raised to 12. So these are the two middle terms of this binomial expansion. Next problem is, in the expansion of 1 plus a raised to m plus n, we have to prove that the coefficients of a raised to m and a raised to n are. Now in this binomial, this 1 is a, this a is b, and this m plus n is n. The general term of binomial expansion is tr plus 1 equals ncr a raised to n minus r into b raised to r. In this case, it will be m plus n c r into a, which is 1 raised to m plus n minus r into b, which is a raised to r. Comparing this a raised to r with a raised to m, we get r equals m. So the general term will become t m plus 1 equals m plus n c. This r will be m into 1 raised to m plus n minus r, which is m, into a raised to r, which is a raised to m. So this will be m plus n cm 1 raised to n, which will be 1, into a raised to m. So the coefficient of a raised to m will be m plus n factorial upon m plus n minus m factorial, that will be n factorial into m factorial. Comparing a raised to n with a raised to r, we also get r equals n. Therefore t n plus 1 will be m plus n c. In place of r we will put n into 1 raised to m plus n minus n into a raised to r, which will be a raised to n. This will be m plus n cn 1 raised to m will be 1 into this a raised to n. Now the coefficient of a raised to n here is m plus n factorial upon m plus n minus n, that is m factorial into this n factorial. which is same as the coefficient of a raised to m factorial. This, therefore, in the expansion of 1 plus a raised to m plus n, the coefficients of a raised to m and a raised to n are equal. In the next problem, we have to prove that the coefficient of x raised to n in the expansion of 1 plus x raised to 2n is twice the coefficient of x raised to n in the expansion of 1 plus x raised to 2n minus 1. First, we will consider the binomial expansion of 1 plus x raised to 2n. The general term will be tr plus 1, which will be 2n c r into this 1 raised to 2n minus r into this x raised to r. We can compare this x raised to r with x raised to n, so that gives us r equals n. Therefore, the general term becomes t n plus 1 equals 2n cn into 1 raised to 2n minus n into x raised to n. So this gives us the coefficient of x raised to n in this expansion as 2n cn, which will be 2n factorial upon 2n minus n, that will be n factorial into this n factorial. This we can write as 2n into 2n minus 1 factorial upon this n factorial will be n into n minus 1 factorial into n factorial. Next, we will find the general term of the binomial expansion 1 plus x raised to 2n minus 1. Here also, the general term tr plus 1 will be 2n minus 1 c r into this 1 raised to 2n minus 1 minus r into this x raised to r. Here also we can compare this x raised to r with this x raised to n. That gives us r equals n. So this general term of this expansion will become t n plus 1 equals 2n minus 1 c n into 1 raised to 2n minus 1 minus n, that will be n minus 1 into x raised to n. So here the coefficient of x raised to n in the expansion of this will be 2n minus 1 cn, which we can write as 2n minus 1 factorial upon 2n minus 1 minus n, that will be n minus 1 factorial into this n factorial. Now we will divide 2n cn by 2n minus 1 cn, which will be 2n multiplied by 2n minus 1 factorial upon n into n minus 1 factorial into n factorial multiplied by reciprocal of this, that will be n minus 1 factorial into n factorial upon this 2n minus 1 factorial. Now this n cancels with this n. This 2n minus 1 factorial cancels with this 2n minus 1 factorial, and n minus 1 factorial cancels with this n minus 1 factorial, and n factorial cancels with this n factorial, which gives us 2. Therefore, we can say that the coefficient of x raised to n in the expansion of 1 plus x raised to 2n is twice, which is this, the coefficient of x raised to n in the expansion of 1 plus x raised to 2n minus 1. In the next problem, we have to find a positive value of m for which the coefficient of x square in the expansion 1 plus x raised to m is 6. In this binomial, 1 is a, x is b, and m is n. The general term will be tr plus 1 mcr into 1 raised to m minus r into x raised to r. Comparing x raised to r with x square, we get r equals 2. General term t 2 plus 1 will be mc2 1 raised to m minus 2 into x square, which will be mc2 1 raised to m minus 2 will be 1, so it will be x square. Now here the coefficient of x square, which is mc2, is given to be 6, so we write mc2 equals 6, which will be m factorial upon m minus 2 factorial into 2 factorial, which is 2, equals 6. This m factorial is m into m minus 1 into m minus 2 factorial upon m minus 2 factorial equals this 2 multiplied by 6, which will be 12. Now here this m minus 2 factorial cancels with this m minus 2 factorial, and we are left with m into m minus 1 equals 12. That will be m square minus m minus 12 equals 0. This can be factorized as m minus 4 into m plus 3 equals 0. That gives us m equals 4 or m equals minus 3. Since we want the positive value of m, so our value of m will be 4 and not m equals minus 3. In the next example, we have to find a, b, and n in the expansion of a plus b raised to n if the first three terms of the expansion are 729, 7290, 30375 respectively. We have the binomial expansion a plus b raised to n as a raised to n plus nc1 a raised to n minus 1 b raised to 1 plus nc2 a raised to n minus 2 b square plus so and so forth plus b raised to n. Here the first term t1 is a raised to n, the second term t2 is nc1 is n. We write this a raised to n minus 1 as a raised to n upon a into b, and the third term t3 is nc2, which will be n factorial upon n minus 2 factorial into 2 factorial, which will be 2, into this a raised to n minus 2 we will write a raised to n upon a squared into b squared. Now we are given the first term a raised to n equals 729. The second term is n upon a into a raised to n, but a raised to n is 729 into b. First we will divide t2 by t1. That will give us n upon a multiplied by 729b divided by 729. Now this is given t2 is 7290 upon 729, so that will be 10. Now here this 729 cancels with 729, so what we get is nb upon a equals 10. Now we will divide this t3 by t2, so we write t3 by t2 as n factorial upon n minus 2 factorial into 2 multiplied by a raised to n upon a squared into b squared. Now this divided by, that is multiplied by, reciprocal of t2, which will be a upon n into a raised to n into b. Now here 1a cancels with this a, 1b cancels with this b, a raised to n cancels with this a raised to n. We can write this n factorial as n into n minus 1 into n minus 2 factorial. So here this n cancels with this n minus 2 factorial cancels with this n minus 2 factorial. So that will be this b into n minus 1 upon this 2a, which will be this 30375 upon 7290. We will divide 7290 by these two, so this will be 2 ones are 2 3s are 6, 2 6s are 12, 2 4s are 8, and 2 5s are 10. We will divide by 5. 5 6s are 30, 5 7s are 35, 5 5s are 25, 5 7s are 35, 5 2s are 10, 5 9s are 45. Then we will divide by 3. This will be 3 2s are 6, 3 2s are 6, 3 5s are 15, 3 2s are 6, 3 4s are 12, 3 3s are 9. Again we will divide by 3. So that will be 3 6s are 18, 3 7s are 21, 3 5s are 15, 3 8s are 3 1s are, then 9 9s are, 9 7s are 63, 9 5s are 45, and finally 3 3s are 9, 3 2s are 6, 3 5s are 15. So this will be 25 upon 3. So what we get here is NB upon A minus B upon A equals 25 upon 3. But this NB upon A equals 10. So we write B upon A equals 10 minus 25 upon 3. So that will be 5 upon 3. If we put this B upon A equals 5, this 5 upon 3, then we get N into 5 upon 3 equals 10. So it will be 5 ones are 5 twos are. So that gives us N equals 6. So that is our first value. N equals 6. Now here A raised to N is 729. So we write A raised to 6 equals 729. But 729 is 3 raised to 6. So this implies A equals 3. So that is our second value, A. Now since this B upon A equals 5 upon 3, so we write B upon A, which is 3, equals 5 upon 3. Now this 3 cancels with this 3, and we get our third value, B equals 5. So we got all the three values, A equals 3, B equals 5, and N equals 6. Friends, if you like this video, please click the like button, share this video with your classmates. Don't forget to subscribe this channel to get more videos of this type. Give your comments to make these videos better. You can suggest topics on which you want me to make videos. See you in the next video. Until then, keep watching Number Collage. Thank you.